Welcome to G Fun Facts Online. Imagine this. 11 million years ago, over the vast, arid expanse that is now South Australia, the sky rips apart. A fiery rain, not of water, but of molten alien green jewels, pelts the Earth. This wasn't a weather phenomenon. It was the aftermath of an asteroid striking our planet with unimaginable power. For millions of years, the only evidence of this cataclysm lay scattered and hidden in plain sight, waiting to be understood. Recently, scientists have finally pieced together the story from these tiny, glassy clues. They've uncovered a previously unknown massive impact event that rewrites a chapter of Australia's violent geological history. These aren't just pieces of glass. They are tektites, natural glass, forged in the crucible of a cosmic collision. And this new discovery, named ananguites, represents the sixth major tektite field ever found on Earth. For decades, these specific glassy objects were mistaken for an odd subgroup of the more famous Australasian tektites, which were formed from a much younger impact only 780,000 years ago. But a team led by PhD student Anna Mussolino of Aix-Marseille University has proven they are from a completely separate and far more ancient event. So, what exactly are tektites? The name comes from the Greek tektos, meaning molten. When a large asteroid slams into Earth, the sheer energy melts surface rock and soil, blasting the molten material high into the atmosphere at incredible speeds. As this fiery rain of liquefied Earth falls back, it cools rapidly, solidifying into glassy, pebble-like objects. They are found in specific, large regions across the globe known as strewn fields. Before this discovery, we only knew of 5. Tektites are distinct from volcanic glasses, like obsidian. They contain almost no water and lack the tiny crystals found in volcanic rocks. Crucially, they often contain lecatelierite, a form of fused silica glass that is a definitive sign of the extreme temperatures only found in meteorite impacts. Their shapes are sculpted by their rapid spinning journey through the air while still molten, resulting in spheres, teardrops, and even dumbbell shapes. The story of identifying the ananguites is a fantastic piece of scientific detective work. The first clue was their density. These tektites consistently sank in heavy liquids that other tektites floated in, pointing to a different chemical makeup. Sophisticated geochemical analysis then revealed their unique fingerprint. Ananguites have what's called an andesitic composition, similar to certain volcanic rocks, which is unusual for tektites. More telling, they contain up to 15 times more nickel, chromium, and cobalt than typical crustal rocks. This chemical signature is a smoking gun, pointing to contamination from a chondritic meteorite, the most common type of space rock. The final, definitive proof came from argon-argon dating performed at Curtin University. This technique acts as a geological clock by measuring the decay of radioactive potassium into argon gas trapped within the glass. The results were clear and consistent. The ananguites were all approximately 11 million years old, placing them in a league of their own, completely separate from any other known event. The known ananguites have been found scattered across a vast, 900-kilometer-long elliptical area of South Australia, centered around the starkly beautiful region of Kadithanda Lake Eyre. This distribution provides crucial clues. In a tektite-forming event, the largest fragments are thrown the farthest. The sheer size of this strewn field suggests the impact was colossal. And yet, this leads us to the biggest mystery of all. Where is the crater? Finding an 11-million-year-old crater is a monumental challenge. On land, erosion can erase even massive scars. But the chemistry of the ananguites themselves tells us we should even be looking in Australia. Their andesitic composition doesn't match the Australian continental crust where they landed. Instead, it points to a target rock found in active volcanic arcs. Based on isotopic analysis and the trajectory implied by the strewn field, the team has narrowed the search to the volcanic island arcs north of Australia. Regions like the Luzon Arc in the Philippines, the Sulawesi Arc in Indonesia, or the Bismarck Arc in Papua New Guinea are the most likely candidates. This means the crater is almost certainly on the ocean floor, in one of the most geologically dynamic regions on the planet. It could be buried under kilometers of sediment, or it may have been completely destroyed by plate tectonics, where oceanic crust is constantly being recycled back into the Earth's mantle. This impact occurred during the Miocene epoch, a pivotal time for Australia. The continent, having broken from Antarctica, was drifting north. The climate was changing from warm and wet, supporting lush rainforests, to the more arid continent we know today. Miocene Australia was home to incredible megafauna, flesh-eating kangaroos, giant thunderbirds, and marsupial lions. An impact of this magnitude would have been devastating. An initial blast would have incinerated a vast area, followed by earthquakes and, given the likely oceanic impact, colossal tsunamis. Dust and aerosols thrown into the atmosphere could have triggered an impact winter, blocking sunlight, crashing global temperatures, and collapsing food chains. For the unique life of Miocene Australia, this would have been a catastrophic blow. While the science is new, the human connection to these objects is ancient. For thousands of years, Aboriginal peoples have found and valued tektites, or australites. They weren't just rocks. They were sacred objects imbued with power, used in rituals for healing, rainmaking, and hunting. The name ananguites is a tribute to the Anangu, the Aboriginal people and traditional custodians of the land around Katy Thonda Lake Eyre, where these glassy tears from the sky rested for eons. The discovery of the ananguites is a powerful reminder that our planet's history is punctuated by cosmic violence. These small, dark pieces of glass are clues to a long-lost cataclysm, providing a new data point for understanding the frequency of large impacts, knowledge crucial for planetary defense. The hunt for the phantom crater will continue, but for now, the ananguites themselves tell a remarkable story of an 11-million-year-old asteroid, a fiery rain over a changing landscape, and a mystery that connects the deep, arid heart of Australia to a violent, hidden event in the volcanic seas far to its north.